So, rules for naming aldehydes. And again, we're following the same general pattern. We take the parent carbon chain, that's the longest chain, and this has to include the carbonyl group. So you can't ignore the carbonyl group. It has to include the carbonyl group. You're going to change the name of that parent chain by dropping the E from the alkane name and adding AL for aldehyde. So here's where spelling becomes important, because if it was OL, it would be an alcohol, but this is AL. Then we're going to number the parent chain. The carbonyl carbon is going to be number 1. Aldehydes always have the carbonyl group on the end. It's always number 1. So then we don't include the number 1 in the name because it's always 1. And we don't write number 1s that aren't essential. But that's how we number the chain from the carbonyl group. Then you indicate the identity location of any other substituents in front of the parent chain name. Now, when you have an aldehyde functional group attached to a carbon ring, you're going to name the ring and then use carbaldehyde as the parent name. And we'll do some examples. So let's name these guys. So letter A here, we need to find the longest chain. It has to include this carbonyl carbon. This is going to be 1, 2, 3, or 1, 2, 3. It's the same difference. 3 carbons is what? Mom eats propane. So from propane, we get, I can't spell, propane, we take off the E and add AL. So propanal. This is 1, 2, 3. On the second carbon we have a methyl group. So we're going to say 2-methyl propanal. Make sense? Let's look at this one. This one's a little bigger. What's the parent chain? I get 1, where's my pointer? 1, 2, 3, 4, 5. Or 1, 2, 3, 4. But 5 is longer. Right? So 1, 2, 3, 4, 5. So our longest chain is pentane. Pentane becomes pentanal. We don't need to write 1 because the aldehyde group is always on carbon number 1. And then what's attached to this chain? We got this guy right here. What's the name of that? Ethyl, and that's on carbon number 2. So 2-ethyl pentanal. Hyphens between letters and numbers, commas between numbers, and like ethyl pentanal, we just run those together. I was not planning ahead very long. Let's do a couple more. Okay, so the longest chain for letter C, this is more straightforward. 4 carbons, right? 4 carbons is butane. So butane becomes butanal. This would be 1, 2, 3, 4. And now we've got chlorines here. We haven't seen halogens for a while. It's chloro. There's 2 of them, so dichloro, and they're on carbons 2 and 3. So this is 2, 3, dichloro. Last time I left too much space. Dichlorobutanal. The only way to tell if you understand this is to do the homework problems and see if you're getting them correct. And if you're not, make sure that you understand why the correct answer is what it is. If you don't understand, text me and ask me, and I'll be happy to tell you. Okay, so this one. Here we have our aldehyde. It's a carbonyl group with a hydrogen, but what's it attached to? This ring, right? So this is rule number 5 from that previous slide. We name the ring, and then we say carbaldehyde. So this is cyclopentane, right? I think it's pentane as opposed to cyclopentyl. Let me just double check. Yeah. Cyclopentane is the name of the ring. It's not named as an alkyl group. Cyclopentane carbaldehyde, all together is one word. Y kind of got messed up. I don't think we'll run into those very often, but there they are. Any questions? And of course, then we have to have some common names. The common names for aldehydes are a little bit unusual in that they just have a single name instead of two names. So here are the 4 smallest aldehydes, and they use different counting prefixes. Okay, so we have become familiar with meth, eth, prop, and bute. Good grief. You know what, I'm just going to move those. There's more space on this side. So we were familiar with these. Where am I? 1 was methyl. 2 was ethyl. 3 was propyl. And 4 was butyl, or butane. And we said Mom eats pickled bananas. Well, for aldehydes and for carboxylic acids, the prefixes are different. And for 1, we've got form. And for 2, we've got acet. And then 3 and 4 are similar, but not quite the same. Propio and butyr. Personally, I'd have them be the same, but it's not up to me. So we remember these guys by saying, Mom eats pickled bananas. One of my classes came up with, Father ate pickled bananas. I guess Dad's smarter because he did it once and realized that pickled bananas are not a good thing to be eating, and Mom continues to eat them. I don't know. Whatever works. But formaldehyde. This is an aldehyde. Here's the carbon-oxygen double bond and the hydrogen. Formaldehyde has 1 carbon. It means that there's 2 hydrogens bonded to this. This carbon does not have to have a carbon bonded to it. The stipulation is it has 1 hydrogen. So that's the smallest one, formaldehyde, 1 carbon. This is acetaldehyde. It's got 2 carbons. Propionaldehyde has 3 carbons, and butyraldehyde has 4 carbons. There are no positional isomers for these because the aldehyde group is always on the end. So those are the common names for the aldehydes. And then, of course, they could be substituted. We can also have aromatic aldehydes. And these are named as derivatives of benzaldehyde. So here's benzaldehyde. This is benzene aldehyde, right? It's a benzene with an aldehyde group on it. So this is another one of those monosubstituted benzene rings that has a special name. So you should know this guy, benzaldehyde. At least the name is suggestive of what it is, benzene and aldehyde together. And so then you can have substituents on this. Again, the aldehyde group would be number 1. And so for this one, we could count 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. We're going to end up with a 3 and a 5 either way. And here's where we use the alphabet to break that tie. We're going to number it to give the chlorine group the lower number, because we would end up with the same numbers either way. So 3-chloro, 5-methyl benzaldehyde. This one is named as 4-hydroxy benzaldehyde. Now, this is where we get into priorities. Because this guy right here has a special name, doesn't he? That's phenol. Why don't we name this as a substituted phenol? Because aldehydes take precedence over, they take priority over alcohols. So here's the list of things we've covered so far. So aldehydes are at the top of the list. If it's got an aldehyde group in it, you name it as an aldehyde and everything else becomes a substituent. Ketones are next, then alcohols, alkenes, alkynes, alkoxy, those are the ethers, alkyl, and then halogens. These guys at the end here are actual equal priority substituents. So this guy here, which has an ether in it and an aldehyde, aldehyde is a higher priority, and so it's named as an aldehyde. So this, oh, come on. Drawing mode, come on. This is a substituent on the aldehyde. So we've got 2 carbons, that's ethanal, and this is methoxy. The methoxy group is on the 2nd carbon. This is carbon number 1, this is carbon number 2. I'm curious, actually, to see if you really need the 2. Because is there anywhere else you could put the methoxy group? You can't put it on carbon number 1. So I'm not sure about that number 2 there, but we'll trust the book person. This one is an aldehyde and an alkene. It's got 2 functional groups. So the priorities are used when you have 2 functional groups. This is the aldehyde group. That's more important. So we say we're going to name this as an aldehyde, and then it's got this along with it. Analogy for real life. So you've got a bunch of animals, and they have different qualities, right? So here's something that's black, and it's a dog. Do we call it a doggish black animal? No, we say it's a black dog. It's more important that it's a dog, and it happens to be black. And so we have these sorts of priorities in our everyday language. We just maybe haven't thought about them that way. But here, the aldehyde is most important. And so we name it as an aldehyde, and everything else is a substituent. So this becomes 2-propene-al. Because this guy right here is 3 carbons, right? That would be propene because of the double bond. We're going to number it with the aldehyde being number 1, 2, 3. So propene-al, the E comes from there being the double bond. Instead of propanal, without a double bond, it's propene-al, and the 2 tells us where the double bond is. This one at the bottom is, it's got an alcohol group here and an aldehyde. So we name it as an aldehyde. It's got 3 carbons, so it's propanal. And there's a hydroxy group on the 3rd carbon, so 3-hydroxypropanal. And generally speaking, we're going through these in order of increasing priority in the textbook. And so if you can remember which one we learned most recently, that's the more important in priority.